Hello, welcome. In this short video, let us look at a parametric PDF and derive the necessary and sufficient conditions for these parameters so that this function is a true PDF. It is given the following function, that is fx of x is equal to ax square plus bx for the value of x between 0 and 1. That is, x lies between 0 and 1, but it is not equal to 0, and the value is 0 otherwise. So now we want to derive the necessary and sufficient conditions for a and b such that fx of x is a true PDF. That is, a function is a true PDF if it satisfies the two axioms of probability. That is, the first one is the PDF should always be non-negative. The second one is its total area should be equal to 1. So by using the first condition, we have ax square plus bx is greater than or equal to 0 for values of x between 0 and 1. That it lies between, it's a proper fraction and greater than 0. So by using this condition, we have x into ax plus b is greater than or equal to 0. And since x is greater than 0 and less than 1, this inequality basically means that we can cancel the x and we have ax plus b is greater than or equal to 0. This is the first condition. The second condition is integral fx of x dx is equal to 1. That is, area under the function is equal to 1. So by using the definition, we have integral 0 to 1 ax square plus bx is equal to 1. By continuing with the integration, we have ax cube by 3 plus bx square by 2. Limits are 0 and 1. This should be equal to 1. So by inserting the limits, we have a by 3 plus b by 2 is equal to 1, which implies that the condition is 2a plus 3b is equal to 6. So the necessary condition is ax plus b should be always non-negative, and the sufficient condition is 2a plus 3b should be equal to 6, and for the values of x between 0 and 1. So these are the conditions for the PDF to be, the function to be a valid PDF. Now we can further analyze these conditions since we know the interval for the value of x. So for the case when x is very close to 0, that is, it gets close to 0, we can evaluate the limit for the value of a as limit x tends to 0, ax plus b should be greater than or equal to 0. But from the condition 2, that is, we have 2a plus 3b equal to 6, b should be equal to 2 minus 2 by 3 into a. So by using this value, we can evaluate the limit as limit x tends to 0, ax plus 2 minus 2 by 3 by a should be greater than or equal to 0. And now by using the limit, we have at the limit, this basically becomes 2 minus 2 by 3 by a is greater than or equal to 0, which implies that a should be less than or equal to 3. And for the value of x, that is the other extreme of the interval, that is when x is equal to 1, for x equal to 1, we have a into 1 plus 2 minus 2 by 3 into a should be greater than or equal to 0. This basically means that a by 3 plus 2 should be greater than or equal to 0, which means that a should be greater than or equal to minus 6. Therefore, the valid interval for the value of a is, that is, a belongs to the closed interval minus 6 comma 3, and whereas b is equal to 2 minus 2 by 3 into a. Thanks for watching.